This is page number 51, chapter number 3, coordinate geometry. What is the good of Mercator's north poles and equators, tropics, zones, and meridian lines? So the bellyman would cry and crew would reply. They are merely uh, conventional signs. Written by Louis Carroll, The Hunting of the Spark. See, this is related to the coordinate geometry, that's why it is written there by Louis Carroll. Now we will go further. 3.1 introduction is there. You have already studied how to locate a point on a number line. You also know how to describe the position of a point on the line. There are many other situations in which to find a point we are required to describe its position with reference to more than one line. For example, consider the following situations. First, in figure 3.1, there is a main road running in the east-west direction and streets with numbering from west to east. Also on each street, house numbers are marked. To look for a friend's house here, is it enough to know only one reference point? For instance, if we only know that she lives on street number 2, will we be able to find her house easily? Not as easy as when we know two pieces of information about it, namely the number of the street on which it is situated and the house number. If we want to reach the house which is situated in second street and has the number 5, first of all we would identify the second street and then the house number 5 on it. In figure 3.1, H shows the location of the house. Similarly, P shows the location of the house corresponding to the street number 7 and house number 4. Second, suppose you put a dot on a sheet of paper, figure 3.2a. If we ask you to tell us the position of the dot on the paper, how will you do this? Perhaps you will try in some such manner. The dot is in the upper half of the paper, or it is near the left edge of the paper, or it is very near to the left hand upper corner of the sheet. Do any of these statements fix the position of the dot precisely? No. But if you say the dot is nearly 5 centimeters away from the left edge of the paper, it helps to give some idea, but still does not fix the position of the dot. A little thought might enable you to say that the dot is also at a distance of 9 centimeters above the bottom line. We know we now know exactly where the dot is. For this purpose, we fixed a position of the dot by specifying its distances from two fixed lines, the left edge of the paper and the bottom line of the paper, figure 3.2b. In other words, we need two independent informations for finding the position of the dot. Now perform the following classroom activity known as sketching plan. Activity number 1, sketching plan. Sorry, this is No skating. This is sitting plan. Sorry. This is sitting plan. Draw a plan of sitting in your classroom, pushing all the desks together. Repeat each desk by a square. In each square, write the name of the student occupying the desk which the square represents. Position of each student in the classroom is described precisely by using two independent informations. Number one, the column in which she or he sits. Second, the row in which she or he sits. If you are sitting on the desk lying in the fifth column and third row represented by the shaded square in figure 3.3, your position could be written as in bracket as ordered pair 5 3. First, writing the column number and then row number. Is this the same as 3 comma 5 in bracket? Write down the names and the position of the student in your class. For example, if Sonia is sitting in the fourth column and first row, write S in bracket 4 comma 1. The teacher's desk is not part of your sitting plan. We are treating the teacher just as an observer. In the discussion above, you observe that position of any object lying in a plane can be represented with the help of two perpendicular lines. In case of dots, we require distance of the dot from bottom line as well as from left edge of the paper. In case of sitting plan, we require the number of column and that of the row. This simple idea has far reaching consequences and has given risk to be very important branch of sorry has given rise to a very important branch of mathematics known as coordinate geometry. In this chapter, we aim to introduce some basic concepts of coordinate geometry. You will study more about these in your higher classes. This study was initially developed by French philosopher and mathematician René Descartes.